Hello, and welcome back to another Binary Ninja stream. My name is Kyle Martin, and today we're going to be looking at a couple of Pwn challenges, some old Pwn challenges, nothing with too many protections in them, no like speculative execution protections, no fancy got protections. For some of these, there won't even be canaries, I think. But I do have some that are latest protections if we want to get into them. But mostly, I think we're going to do a shellcoding challenge, a ROP challenge, and then we'll take a peek at a heap challenge. I don't plan to fully exploit it, but there is one trick that I think is really nice that I want to go over. So, um, also, 5.3 is out, so if you haven't updated to stable yet already, go ahead and do so. There's a lot of nice features on there already. I believe the three biggest ones so far are that we have these type fragments, type slices added, which is super exciting. This is something I've been waiting for a while. If a function takes just a part of a structure, but not the whole thing. It's very useful. And then we've got the new plugin manager is in as well. I go over here and I click on my plugins in the bottom right, you'll notice that you have two tabs now. You've got your available plugins and you have your installed plugins over here. So it's nice just to see everything you've got installed in one place. We're going to show local plugins here soon after we fix a couple of bugs in this that we found, but you guys should have seen the migration dialog, which will be giving you the will migrate all your old plugins into the new plugin sort of layout. With this, there's a ton of plans. We're going to be getting native plugins before the next stable, we hope, we believe, in here. So if you have any Rust or C++ plugins that you've been sitting on or that you've been wanting to write, they'll be able to, well, get on them, start working on them, because you'll be able to get them in the plugin manager soon. There's a handful of C++ plugins I definitely think I would write, will write once we've got support for that. And of course, subscribe to the stream because we'll be doing that here as well once it's out. And the next thing I believe coming on to dev soon, at least before this next stable, one of the other big features of this release is going to be the TMS 3200, 3200. But I don't think that's landed yet. I believe there might be a couple architecture fixes landing before then. All right, so then without further ado, let's get shellcoding. This challenge right here is from, where'd my notes go? It's almost certainly from one of the seesaws. We're doing a handful of seesaw challenges today. Largely, here we go. So this one is shell point code, and it is from Seesaw 2018 quals. Simple shell coding challenge here. I've got it in this, I believe it's a 2204 VM over here. And if we run, we have checksec on here, right? Oh, we don't have checksec on here. Do I have this binary locally? I do. So if we run checksec over here, um, we'll see that it has no stack canaries. It is position independent. The stack is executable, and has no RWX segments, and it's not stripped. So that's good for us. We can make use of that. An executable stack means we can potentially throw some code on the stack and then jump to it. So we'll see how we do that. We've got some set buff things here. Linked lists are great. They let you chain pieces of data together. This node function gives me a handful of things here. Let's reverse this real quick. We've got something at the top. We've got an alias to it, which we are printing 28 and 48. It doesn't seem like we interact directly with 48, but this is going to print whatever is at that address and then the address of one after it. So, oh, and we have the string right there. Next and buffer. So that's helpful. No, in this function, we also have a couple weird fields. Read line this first one, the text for node 1, text for node 2. So let's go ahead and rename these. Oops. Um, node 1, where are we? Node 2. All right, and then these are going to be, it's saying 18-byte character arrays, but I don't believe it. Let's go ahead and make an 18-byte structure to apply there instead. So, if you'd like to follow along, all these challenges are open source. Just look for the Seesaw 2018 Qualls repo online. I actually have it open here. I almost have it open here. I have a different version of them open. There we go. So this is the Pwn category in here. We got shell point code. I also get it downloaded, but I'm not sure we're going to do that one. And there are solves for this, but we're going to do it ourselves. All right. So we'll go ahead and make this node structure right there, 18 bytes, and apply it. So now we have two nodes over here on our stack. We still have this alias variable. We're getting the address of it, and then we're getting the address of that. But we're using that as, I believe, a node. So if we make this a node pointer, we see a couple offsets in there, which we can update into our struct over there. We don't see a third field. Oh, but this is a string. So this field is not going to just be 8 bytes. In fact, if we go up, it looks like we read all 16 bytes in there. So let's go ahead and name that. That's going to be, there we go, a character array of 16. Perfect. Okay, so now if I go back into print node, it looks a little bit better. I believe that's going to be called the text for node 2. So let's just call this text. And then I think we have our alignment slightly wrong here. We've got our arg field 1, which is going to be a next field. Presumably it's going to be to a node pointer. So let's go to another node, I should say. So let's go ahead and make that clear. We're printing node next, but now we're not seeing any parts of those nodes. Oh, here we go. Okay. So we need to move our nodes up by 1, it looks like. What does this read line do? Let's come back to that in a second. Let's readjust these. So now this is node 2, and this is node 1. All right. It looks like there might be 8 more bytes here. Am I doing this right? We've got the address of the text. So this might just be a pointer instead of the actual string. No dot text. So this is going to be the destination, right? Um, destination. Here it is. We're copying into the destination. We're getting a line. We're getting up to 16 bytes. Yeah, okay. Oh, we already have an n. Let's call it count then. All right. So that looks pretty good to me. Um, and we are just copying into that buffer. So yeah, I think that's good. And I think there's just a little bit of padding between these two structures. But if we're wrong, we'll figure that out later. Um, print node, goodbye. Okay. So, and then we call it goodbye. So then what's the bug here? We have, um, we're getting a stack address, so we're leaking that. And then node 1.next is node 2. Good, that's good to see. Um, reading into those 16 bytes. Mhm. Let's go ahead and start writing our handlers for this. So I've got the beginnings of a Pwn'tools script here for us, just a template for us. And it's just we're importing Pwn, setting up the context, launching it under a debugger. There are some things for me to copy and paste here, and then we're dropping an interactive. So if I run this over here, I'll need to start Tmux, and we'll need to say hello to my Stegosaurus. Go ahead and run the solver. It looks like we get there's a little bit too much on the screen. All right. So on the right, we are in the target at our breakpoint. I broke on main, didn't mean to do that. Let's do, yeah. So I can just continue over here. We're going to get, there we go. 15 bytes text for node 1. Okay. So this is the first thing we're going to be getting from the program. So we're going to receive or send after, actually. Is probably better here. So we'll receive until that. SD. Okay. Let's go ahead and just run the program normally as well. Shell point code. And then we get the lines for 2. Initials. Ah, I didn't notice that. Where are we doing? What are your initials? We're reading into this character buffer, and that's how we're getting our return overwrite. This character buffer here is certainly not 20 bytes large. Um, oh, and then we actually print that as well. Um, so we could potentially leak more with that, but probably not that useful. How much of a write do we need here? We need, interesting. Can't seem to click that offset and click all the others. Um, Funny, that's not one I've seen before. But we should just need to overwrite 11 bytes? 1, 2, 3, yeah, plus the 8. Um, and then we have our return address there. All right, so let's finish this script here. We have our text for node 1, we have our text for node 2. We don't know what our payload is going to be yet. So I'll just delete that. and then put something temporary in there for now. And then it asks, oh, we get our leak, so we need to process that. And then it asks, what are your initials? So let's grab that. And that one we can actually build a little bit of the exploit for here. We know we need to send 11. Then our packed, this is going to our, I'm just going to call it jump target for now. And I'll set our jump target to be 4As. All right. So that should be able to run the program for us. And we crash and we are, is our IP just out of frame here? Oh no, we are at 414141. So perfect. We have control over the instruction pointer like we thought, because we can overflow this buffer and directly right into it with no stack canary. And we are destroying our stack with whatever we're putting in there. But that's potentially fine for now. So if we continue through down this line here, we can control to anywhere. Let's go grab our leak now, actually. That would be good. If we have... Oh, I'll just steal this. So what exactly was it printing before? It says there's a lot of stuff there. Let's just run it again. Shell point code, ASD, ASD. Okay, and then it prints node.next, and we just want to receive until that. That's going to be here, node.next, and then we will receive until the new line. We will drop the new line, and we will convert that 16-bit integer to a leaked. Let's do what the AI is suggesting here. Print the leak, make sure that it's actually processing correctly. And it looks like it is. And now where exactly is that leak pointing? We've got, is it the beginning of the print node here? arg1.next. So that is the address of node 2. So we'll just save that as node 2 address. But remember, in node 2, the first thing of node 2 is next. So the actual user controllable buffer on the stack are these two 16-byte fields. And we get the address of 8 bytes before our first one. So now the question becomes, what do... Oh, okay. So we actually, since we have that address, we can jump directly to it in our script over here. We can say our jump target now is, yeah, just 8 bytes after the beginning of that structure. So we're jumping right into the 16-byte field. But 16 bytes is not a lot. A single x86 instruction can be up to 16 bytes. So thankfully we have two buffers, so we might need to use the linked lists to link our shellcode together. But let's see how small we can do. We can get it. Is there anything we need to confirm at the moment? I would like to make sure that we are jumping where we think we're jumping, just so we don't have to debug that later. Let's see here. What do we want to do? instead of sending ASD, we know that this is going to be our first 16 bytes of shellcode, and then we have our second um, 16 bytes of shellcode. So the first one, I kind of just want to send a couple of nops. Slash x 90 and send a handful of those just to see, just to see. And then I know that the address of node 2, node 1, let's do buffer address, and let's turn this into the buffer address as well. Just do the +8 there. That's node 2. Okay. So fairly simple script so far. Just starting it, we are sending nothing. We're sending, we should probably send something. Um, so it's not completely empty. So we'll send a couple nops for both. We'll jump to it. And, oh, that's actually, an int3 is a 61, right? Or 61. Just gonna check it the easy way. Whoops. There we go. I changed the wrong one. Let's change here. Oh, 63? I'm not sure why I'm forgetting this. I forgot this the other day too. Um, CC. Okay, there we go. So we will actually make this a CC. So we will do a breakpoint here, and hopefully we'll see that our address matches um, what we printed, and I'll make that nothing for now. We'll send a breakpoint into nops. Solve. Yeah, that should be good. And node buffer one address is not defined. That is fair. I should probably finish that line. So then, if we have this address here, let me undo all my patches. Okay, there we go. I could also check the history widget here. Yeah, we're good. That would have been the easier way. Um, Now we can, okay, so we have this address to get the second buffer. It's just 20 after that. Perfect. So it's going to be this plus 32, I should be saying technically, but hex 20. Just double checking that. I believe that's correct. So then, we can actually fully verify this chain potentially. If I say, oh boy, let's go over here. We have this call instruction, but it's a call relative. So yeah, I can do a call plus 20 here. Will it let me do it like that? No. Okay. Will it let me do it like $? No. Oh, that's funny. Plus 20, will it let me? Come on. Ah, perfect. Okay. And now that's navigating me to 747. So like between these two instructions. All right, perfect. But I can copy those bytes and put them in my shellcode. And I'm hoping the endianness on this is correct. We're gonna hope. Um, yeah, we'll see. Oh, and that needed to go in the second one because we get the second part of the shellcode first. Okay, so we should run this, hit a breakpoint. We should be able to verify that's inside the beginning of node 2's buffer. And then once we continue, we should jump to the beginning of the second buffer, hit another breakpoint, and we can continue from there. I could, if I really want to, send us back to the first buffer or the second buffer, but let's just run this, see how it goes. We've got the solver. It looks like we have stop for sig trap. We looks promising to me. Where'd we say? Here's our node 2 address. And it looks like that's an exact match, +1. Um, and then we're going to call 789. That math doesn't quite math to me. 69B as opposed to 98. That's that. Yeah, so that's not quite right. Um, but we're not that far off. We wanted to get to 797, I think. We're 4 off. Why would we be 4 off? Oh, because I forgot to consider the length of the call instruction. That's 5-ish bytes. Let's try it. But I'm 4 over. So I want to take 4 out of this byte, go from B to A to 9 to 8. I hope this is a fun one for you guys. A little bit of something different, actually, pwning some challenges. This looks better to me. We don't do a lot of just solving challenges on. Oh, perfect. Okay, so I can continue. All right, cool. So then if I actually could just run this whole thing, I can continue. Perfect. All right. We're golden, guys. Now we can put whatever shellcode we want in here, as long as they are each less than 16 bytes. Okay. So now we should be able to get our shell. I'm going to do that as a jump there. Make a new buffer for us. Okay. So, yeah, as I was saying, I hope you guys enjoy this. We don't do a lot of pwning on stream, but I figured why not? We have some easy challenges here. Might as well. So there's a couple ways now we can get some shellcode. I'm going to grab the shellcode Pwn'tools gives us. Um, which we're going to need to process a bit. So let's just take a look at what the shellcode they give us is. Um, I'll do this as a part of my script here, but maybe we don't run the program. This is our entire exploit so far. So let's just comment that out. Not sure we're going to be using that. We are going to be using these two lines though. So if we, that's the one I wanted to do. If we print this, what do we get? Um, ah, and the hint is, well, I already know what it is. You can kind of see from there what it's going to give us. But if we run this, we should get a p is not defined. Correct. I'm actually okay. That we're just gonna live with that error for a minute. Otherwise, I'm gonna forget to comment it out. Or yeah, uncomment it out. So this gives us just a string. It looks like it tries to call exec on bin slash sh. We've got a big string here. We do some interesting things, and then we call this is call. So how many, let's compile this and see how many bytes it compiles down to. Let me snap that to the left, snap this to the other way around, snap that to the right, snap that to the left, and we can compile this shellcode. I assume it can be compiled like that. Um, let's give that a go. We should print our shellcode and the length of it as well. Hopefully this is less than 32 bytes total, but we actually want it to be a little bit less than that because we have our trampoline from one buffer to another. But we had, okay, cool. So it is too big. So we can either try to manually pare down this shellcode, which is given to us in an interesting format. Um, This Binary Ninja. So the way I often work with shellcode in Binary Ninja is I make a new file. You can go to the new tab page here, or watch all my keystrokes over there. Create a new file from here, and then you have a bunch of paste from options. This, I think, is, yeah, an ASCII escape string. So you can see this is what we were seeing over here. Now it's just not escaped, it's just the raw bytes. Last one is 0x05, yeah, perfect. And now in Binary Ninja, I can go to linear view and you can make a function at this address. What does it do by default? Okay, by default, there is no default architecture, so you have to tell it which one to make the function as. I just want to make a x86 64 function. There we go. And now when I view this as assembly, we can see exactly what the shellcode was doing and maybe remove some lines that aren't necessary, potentially. Um, like what is this push pop stuff it's doing? I know that our stack should be absolutely broken. So we might not want to use the shellcode at all. Let's, well, the way I usually do this is by just looking it up. x86 shellcode. And there's a couple different shellcode databases. Is this down right now? Let's see. Let's open up preferences over here. This is not a issue I was expecting to have. Let's go into the details. DNS. Um, no, that's still not loading. Strange. All right. Other pages are loading though. Unfortunate that that's down. Hopefully that's just temporary. That would be an unfortunate loss. Um, but we can look for some other shellcode. Um, I don't think that one's as good. This one I've had trouble with in the past. This one's just too big for us. We need pretty small shellcode at the moment. I suppose we could always write our own, since everything appears to be offline. Might just be a little bit slower. Um, so ultimately we need to call the right syscall here. Um, oh, are we not moving into... So if I open this up again, open up a new file, we can paste from our escaped string, which now just has RAX in it. I want to copy this out. Paste from ASCII string. We will go to linear view again. We will create a function at this address. Make function at this address, x86. All right. So I don't want to do any of these pushes or pops. I suspect it's just trying to make a small instruction here. Probably. Um, but let's just make this a mov. EAX is probably smaller. OX3B. Oh, yeah. All right. Let's put that. It clears EDX, which is strange to me. And now that's taking up 5 bytes. Yeah, that's 5 bytes. What would be the size of a XOR EAX? EAX, that's 2 bytes. Add EAX O3B, and then that's 3 bytes. So that's the same. If I did just AX, it's somehow bigger. If I do AL, it's 2 bytes. So I can do the MOV in 2 bytes, I believe. Sorry, in four. So that'll save us 1 byte over the MOV itself. And I want everything aligned as best it can be. Let me delete those. Perfect. Um, did I want the 3B? This actually is a fun instance where we can do hex and linear side by side, and it'll actually be helpful. Okay, we don't want that. No, oh yeah, we don't want that 3B, and we do need, we can keep going. Okay, there we go. Perfect, okay. And look, we're down to 30 bytes. So we're getting there. Um, oh, but that's hex 30. So we're down to 32 now. So we need to keep going. Minimizing the shellcode manually. Um, RSI, I assume, needs to have our bin slash bash string in it. It looks like I assume that this is the string. Display as character constant. Oh, yes, that's going to be bin slash bash in little endian, I suppose. Bin slash sh. Um, there's an S. Where's the H? Certainly somewhere. Perhaps. Ah. All right. Okay. We've got that. We're pushing. Where do we pop this? Push, push, push. Interesting. There's the H. Um, what's going on here? So we're pushing. Oh, I see. We're putting all of that on the stack there. Oh, we do need somewhere for it to live. Of course. What do we have in this? I probably should have looked if there's just a win function in here. Or the no sh string. No sh string. Womp womp. But we do know the addresses of everything in memory, which is convenient for us. So in theory, we could just have that string be the first thing in our buffer, jump over it, and then point at it again. I don't know that that's the answer, but we can give it a go. Let's go back to Binja here. Let's go back to our shellcode. So, hmm, we want basically none of that. But now, oh, we do just want this raw string here. I deleted the S. All right. And then let's set this to be a null byte. Okay. And now I've potentially, yeah, you can notice on the left here, I've completely shattered our shellcode. But if I undefine this function and make a new function, I want linear view, I would like to undefine you, perfect. And then the code starts, well, I don't need you either. There we go. the code starts here. So now if I make a function at this address, okay, we get nonsense because presumably I misaligned some things. Okay, perfect. It snapped back into place. Um, so we don't need this push instruction. We shouldn't need any of this XOR baloney. We basically should just need to point RSI at that string and go for it. So I think all of this, right? I just want a new file, paste from, where was that? Over here. Paste from compressed string, drop into linear, make a function at this address. Look at the assembly and just making sure it is ESIRAX for the calling convention there. Yeah, all right. So I'm just surprised by how complicated that is. Um, no, XOR. We don't even need the XOR. Funny that it thinks that EAX is now pointing at bin/sh, but kind of makes sense. We do need the XOR though. We just need now also, first of all, let's just knock all that out. And so I would like to get my current address and I would like to, we can make this shellcode pretty dynamic actually. If I make a label and we call that label, oh, that'll push. We don't necessarily want any of that. So we just want a straight mauve ESI. Um, let's do that. Oh, that's correct. How many bytes is that? Like 5, I think that was. Move ESI. Oh, so the 1223344. That'll just. Oh, really? Still. Um, I wish it would let me cancel that action. Oh no, that seems perfect. Okay, so we set AL to be the right syscall, I assume. We move the address of this in here. Okay. Actually, now that I think about it, it might need to be an RSI move. If I edit this line and I'm gonna put it here. Actually, let's be safe and just put it, we don't actually put it too far. Let's put it here. We'll do 5, 6, 7, 8. So it's the full 8-byte pointer. It also shouldn't have let me try to do what I just did. That's better. And everything looks aligned still. So that right there should be our actual shellcode. And you can see how many extra bytes we have to play with here. So we're actually doing pretty well. I'm gonna just delete them for now. And then we just need to figure out what that address is going to be a little bit dynamically. Um, okay, so let's bring, first of all, my favorite way to play with the shellcode coming out of Binary Ninja is through copy as, and I think I usually like, I think it's the raw hex I like because that gives it to me just as that, but we're actually working in Python, so um, copy as, um, hex dump maybe? No, definitely not hex dump. Copy as binary. Let's just do the 8-bit elements. Okay. From here, I can do some fun keyboard shortcuts to get this to be how I want. Shellcode actually now equals this array. Come on. There we go. And what's fun here is we just need to substitute in our address. Perfect. Okay. Let's make this a little wider. And that address needs to be the address of the beginning of the buffer, which we already have. That is, here's our script. Here's our exploit, I should say. And then we have the node to buffer address. Yeah. Packed. And now, really, we need to offset from this buffer now. And we need to offset by bin/sh amount. Um, oh, that's funny. This is the bin/sh part. This is our mov. That's our address. And then this is our syscolon, setting up the rest of the arguments. All right. We still have to have that potentially. I just want to copy this out as, um, because we should probably define, oh, I need to define this at the top. And then I just want to offset by the length of that, um, by the length of that. So then we're going into the actual shellcode part here. We are assigning that to be there. Okay, perfect. So now what is the length of our shellcode? It should be 8 from that, 9, 10, 18. So all this can't fit already. How big's our jump? 5 bytes. So we need to do, I'm just gonna manually craft this. I probably shouldn't, but it'll be fine. Um, oh, we also only get the address of the second buffer after we send everything that we send. So we can't do this. Curious. All right. But I also don't think we can push to the stack because we by the time we jump to our shellcode, I believe we overwrite, oh, we overwrite RBP, but we don't necessarily overwrite RSI. Ah, okay. So, trouble in paradise. We need to go back a little bit to our OG shellcode here. We can use these two pushes, um, RDI to RSP. That could work. Um, what is this? Why an RI? Curious. Well, you know, as they say, if you don't know what it's doing, assume it's doing nothing. So let's just delete it. Great idea, right? Let's see. Keep all that. RDI. Push data 8. Let me just rebase this at some random address. Remake this function. So I'm not getting um offsets into our shellcode as real physical addresses. Hello? Those are not real bytes. Oh, interesting. It locked that for me. Oh, 5. Okay, there we go. Um, that seems like a bug to me, but I'll look at that later. We've got now this push, this other push. Let me hit R on those. Perfect. And now we're moving RSP into RDI, which is a little bit more what I was expecting to see. We have RSI. Let me look up the it's interesting how we're analyzing this. The stack variable, it's not wrong at all. Var 28 equals 8 plus the address of. Oh, that's how it's figuring out um the stack address. It's still too big for us though. And our resource that I know has a smaller shellcode for this is still gone. Um, I still feel like it's just doing too much though. So, like, basically everything from here to here seems unnecessary to me. But what do I know? Let me go ahead and copy our EAX setup because I like ours better than theirs. Which is going to be 31C0 up until the OF. Um, they've got their syscall, and that's the OF. I want the 4 bytes before that to be those now. And now that just sort of snapped back into place. We have, We have syscall number that. Exec v. What are the arguments? It is just the user and file name. I didn't realize that. Um, that's what I thought. And the other two are just null. And the syscall calling convention. I'm just confused by why it's setting up so many. Oh, because it's trying to be nice and setting up the um it's trying to set up the other arguments for us. Does this talk about the calling convention? Oh wow. Um I didn't realize it had that in here. Yeah, okay, we want our second value in dx and they're putting it in. That's the return value, not the arguments. Um, which makes more sense. Here we go. arg1 is RDI, arg2 is RSI, with RAX containing the syscall number, I assume. Um, Unless I'm being silly, RDI. Yeah, okay. So we have the right syscall number. We need to be putting it in RDI. Um, they're trying to be nice. So we can remove basically anything that talks about RSI safely, I believe. That won't work. Okay. 312, well, that 1C address, looking in the bottom right. So 1C is that 31, and then we go down to the E6 at 29. Um, Perfect. So delete that. We've got XOR. What does that do? We're XORing the data at that address with 01, 01, 01, 01. Doing some weird bit masking on that field. I think this might still be more stuff we don't need. Potentially. This should be all we need. So from 10, from that 6, 8 to the O1s. Okay. Will this work? We push an H, which should be fine because our BP is messed up, but our SP should be fine. We push the rest of bin/sh. We push. Oh, then we actually push the value in REX. Then we move RSP into RDI. Okay, this is the actual shellcode. I hope. And it doesn't need any addresses. Everything should just live on the heap, on the stack. All right, I think we're good. Let's go ahead and copy as the C array, 8-bit elements, throw it over here. And now we're doing things a bit differently than we were before because I was being silly. We don't need this bin/sh stuff. I would like my trampoline back. Here's my shellcode. Okay, cool. My trampoline is back. We're jumping now back to the beginning of that buffer, not somewhere inside of it. And my shellcode doesn't need this anymore. It is this. Do we need to populate this with any arguments? No, I believe we just need to jump to it more or less. Where does that? Okay, so we basically need to do the pushing of bin/sh first, everything through that 50 byte. Ooh, we don't quite have that room. Um, do we suppose? Right, because that only gives us 3 bytes. We need 5. We don't actually necessarily need 5. If we assume the stack will have 3 zeros immediately after our buffer there, we could we could just do that. That's a little risky, but let's risk it. Um, it'll be cooler if we say we did. All right. So we're going to start with this as the first payload. Let me actually just turn this into a byte string real quick. There we go. And how many bytes is that exactly? These are OXD bytes. Yeah, that should be fine. DE. I hope. I hope. We can see if we need to minimize this. But let me just sanity check myself here. The length of that is what I think it is, right? Perfect. Absolutely flawless. So if we go through, that's going to be the first 15 bytes. Then we need to drop in the second 15 bytes. Oops, there we go. I meant to delete that as well. All right, and then that'll be the second part of our shell code. Okay, so presumably this will work. We don't have this anymore. We're not measuring the size of our shell code. We should send the text for node 1, which is going to fill the part of this buffer. Then we are going to fill node 2 with 15 bytes from here, which should fill up this buffer. We are relying on these 3 bytes being 0 on our stack, which is a little silly, but hopefully it'll just work out. And then, though in theory this exploit is could be unreliable. Um, then we get our leak. So we get the address of the second buffer so that when they ask us what our initials are, we overflow past the end of that buffer right in the address of node 2. Node 2 it executes, jumps to node 1, and we should have a shell. If we've been doing this correctly, which things rarely work the first time. Cool. We died. Where did we die? We died at 9A2. A lot of information on the screen, just trying to find things. Where is, okay, my instruction pointer's here, 9A2, which is not, oh, that's our stack, of course. Cannot disassemble from 9A2. Interesting. It does appear like something happened. RSP is 8 bytes off. Do we need to, because we push a couple times, do we need to decrement it? Or rather increment it? I think we do. Although, oh, you know what? Let's go ahead and do something a little bit silly, potentially. I'm going to add our breakpoint back in. And I'm going to move the push until after the trampoline. Okay, we trap. Um, we have our shellcode buffer is at 488, so that is the byte after we just executed. It looks like we have our 2 pushes. Let's just step through this. So we push that. Our stack is pointing at the H. We move. We should push again and then move. We move again. And then this says we call. And what are we calling? We're not quite calling what I expected us to be calling there. Does that end in 622F? Is this what I think it is? Okay. We can go ahead and make a new file again, paste this in from um, an escape string. And now if we drop over to linear and we make a function here, yes, I know it's a breakpoint. Make a function here. All right, it loses its marbles. What did we do wrong? Um, I want the hex view up as well, please. Okay. Um, Initially there was a 50 here. Does adding that back does not make it valid code on the... Oh, so in my head, 7.3, where does this end? It would be really nice if we were not truncating that. When I have then long opcodes on. Oh, I think there is actually, I forget if there's a option for, you can show the, oh, okay, there it is. I forgot that. So there's the separate, show opcode bytes and then the long opcodes. I forgot about that. Okay, so then it doesn't in that 7.3, and then our next instruction should be, okay, so we ended up within E something there. Where did that come from? Oh, that's that. Oh, mm, that is a call. That is a call of plus 20. Okay, from its address. So we have 495 calling 4B2 and 9AB to, is that the, that's not quite the address of that buffer because it should be at, we've got our node to buffer there, right? Node to adder, but that's really the buffer address because it's +8 there. So in the binary, we are here and we are jumping potentially a variable amount because I'm calculating it from the beginning of that. So I actually just need to put a little bit of math in here of, oh boy. It was 4 too many last time. So when it was 9AB, this I believe was 20. Which is that just 20? 27. Because of course. Um, I'm thinking minus the length of the call instruction gives us 22. Oh, it should have actually been 32. So it was 1B, OX1B plus 5 gave us the 32 byte difference there. So if that is, we need to take 1B, OX1B, and what's the math we need to do on this? We need to subtract however much code we've put in here. So shellcode phase 1 is that, and now shellcode phase 1 plus the byte value of OXB1 minus the length of shellcode. This feels a little crazy. And also, like, there's gonna be an off by one here potentially with that, but we'll see. Um, in theory, this should bring us to the beginning of the second address. We know all the addresses, so let's run this and see what happens. Gonna kill that. Gonna run the solver. Our node 2 address is at 38, so we should be trying to call. We had our interrupt. We have our push, push. No, we are missing that second push, aren't we? Yeah, we are missing our second push. Oh, that's because I was going to put it in the second phase, that 50. Okay, we're good. So we should push, move, call, and now SI. Um, that call is wrong. So we're off by our node address is 38. Um, so we should be at 58, but we're calculating for A. So we're 12 off. Ah, yes, that makes sense. Okay. OX27. Okay, yeah, okay. This makes more sense to me. So step, we call CA now, which is still not right. BC, did I not? does this line return? Um, that would explain it. That would certainly explain it. I want the I want that as a byte. Will it know to... I guess we can just P8. Does Pwn'tools let us do that? Oh, it's not installed in this context. Okay, cool. So we'll just P8 that number. Sig trap, we are pushing our H. We are moving our value. We're calling this function, which is now 924. We were at 8F8. So we are exactly, it should have been 1. It should have been ending in 18. So now we're, oh, that's hexadecimal too. So it's not 6 above. It's, did we need that 1B number? Let's just grab the difference here. 8F8. So we're minus, and in hex, 44, there we go, is 2C. So we are somehow, or C, too many. There we go. Oh my gosh, that's the problem. All right, 2F, E8. No. Oh wait, E8, EF0, perfect. Okay. So now we're finally aligned. We can step. We're going to call. We're going to die. F0 cannot access the memory at. Did we go the wrong way? E. Yeah, why is there... Hold the phone. Um, 27 minus... We're jumping. we have 10 here. In theory, we want to jump forward by 20. It's like OX20 minus 5, which is 27, minus however much shellcode we made. Or so I thought. It's hard to see what that resolves to. Let's run this one more time. We've got our solver. We're landing at, we got 3.8, so we should be calling 5.8, which we are. So what was I questioning? Oh, that once we get to 5.8, our shellcode needs to be there. And the first byte of it should be a 50. It should be a push. Um, that was not right. What is here? You cannot read that memory. What is the difference between that and that? Um, a lot. How are we doing that? Because previously, because that can't be a P8, that was 4 bytes. Okay, and now we have something that's still wrong. So we now have that node address. We're calling this address. Which is then negative that number now. I assumed this was packing it little endian. It's not. I want to see. I just want to see what this is. Jump target. All right. And now, where's our call to print? Will that give me what I want? Will that work? No. Because it's bytes already. Okay. So we are OE now. OE. So if we go back to Binary Ninja here, we have our shellcode. I'd like to remove that from it. 0 E, sorry, E looks like I don't know what we're doing with all these functions here. Let's just, I don't love that the AI just has some shellcode cached in there. I don't know what it's trying to get us to shellcode, but not much. Presumably not much. We want, we got all that. Text for node 1, text for node 2. We are just trying to get this manual call to the first node to actually work. So let's keep going. Um, right, we have our 6A73, whatever, three sets of zeros there, ending then in a 50. And if we make this a function, we can also just use, in theory, if you have a default function, you can just use P. But we'll hit P here, and we get that push the mov, the let's play with it in here for a minute. If we do plus OX 20 here, it's 1B. Um, hmm. Hello? What's this doing? If we do a call relative 0, this is some terribly two's complement sort of thing. So if it's 0, it's EF. All right, I'm going to specialize this. We know that we have 15 bytes. Well, we know the exact number of bytes we have here, um, which are D bytes. And then we know we have our do insert here. Oops. Um, I want insert mode. Toggle insert mode. So I'm going to do a handful of 90s in here to start. Um, What do we mess up? That was a 48. Okay. 90, 90, 90, 90. Okay, perfect. So now we have this. We know that we actually have. So this whole thing is going to be d bytes. Let me pad this out to be the 10 we have. Okay. We know that this needs to become. Oh, and then there's 8 bytes in between, technically, right? Because we have our 16, then we have 8, then we have 8 more, and then we have the next buffer. So this is going to become, I'm going to mark, yeah, we can just do them as 90s. Okay, so this is really what it looks like in memory. And if I pretend that all of these are 0, and we make this here a jump to, we've got the 50, which is the push, then we have 390s, then we have a 00, apparently, oh, is that, apparently that's a valid instruction we need to get rid of. But we'll work on that in a second because we need this. If we edit all of, I want you to continue disassembling this. Create function. That was a weird bug. I've never seen that one before. Okay, so now we have all of our knobs. So I want to really make I really need a label to exist in here. Oh, the best way to do that would probably just be by, no, because this needs to exist at its own location. So let's create a new function here. Plugin, nope. Make function at this address. Let's make an x86 function. Okay. And now we can call that function, which is going to be 20 OX20 minus OD. So plus 13, 26, not quite. There we go. So this should be exactly how it is in memory. So those 3-ish bytes should be good. Yeah, that should be good. Um, it's just FF15, oops, FF15, and I don't love the non-escaped version of that. It was OD. Okay. Let's see if this jumps to the right location now. We have lovely. So we pushed RAX, and now we're jumping to RIP plus a very large number. FF1D, FF15OD, FF15OD. All right. I'm trying to compare that to that. All this looks correct. We have our 50 at the end, plus our 3 bytes. It is still possible that the 3 bytes we needed to be 0 are not actually 0. If I examine a couple bytes at that address, we have FF1500E5, FF curious. And what is Binary Ninja saying about that jump? It is calculating a strange number for it, isn't it? Um, and now that is no longer what we want. We try relative jump instead. Um, that could work potentially, but that needs to be that number, which didn't change the instruction, but it's FF2520. FF, oops, 2520. Let's try this one. Okay. Still jump into a really strange spot. Um, destination minus source. Yeah. 20 bytes plus 2, I guess. Or Yeah, almost hex 20 bytes. EB30. Let's just do that one. Um, and then what is the actual offset going to be? So that's going to be 0, 0. Let's toggle insert mode again. And then we get 90 in here. We get EB. Oh no, that's cool to see. Now we just need minus F is going to be 11. Okay, so EB11. Let's try that. This seems a little more promising to me. Um, Perhaps I never should have tried using a relative call. Oh, okay. So we ran the syscall. It does not appear to have done anything because who's to say why? Which byte is the actual syscall? OF05. Let's just insert a breakpoint there and see what happened. Okay, we're in our sig trap. We're about to call syscall. RAX is 3B. RDI, which is what we're setting, is equal to um is it $ RDI? N/sh. Okay, that looks good to me. And then we might need to XOR other variables, but if I just continue, we get a sig fault. What did our stack look like? We're at the syscall. Our stack looks relatively sane. We have our registers are all relatively sane, except for our base pointer. Do I need to maybe just give ourselves a real base pointer by saying something like so then we jump. I'm gonna make all these 90s. And then up here, really, I want to insert again. Insert. But before we insert, let's overwrite these nops. This I want to say. Oh, those nops came out of the function. Um, cool. The nops are their own function now. I want this to say move RBP, RSP, and then either add or subtract to it. Move RSP, or sorry, RBP, RSP, which is only a couple bytes, and then let's just offset it by 100. Ooh, that's a bigger instruction. Will that still fit? That one is 7 bytes. That one is 3 bytes, so that's 10 bytes. That is surely more than 6 bytes, yeah. So that's smaller. That is smaller by a byte. So now that's 9 bytes. This is 9 bytes, that's 18 bytes, but we need to do 16 bytes. Um, is OX100 a bad choice? If I did um decimal 100, it's much smaller. Okay. So let's try that. And we're going to we can do that. Yeah, we can do that first. Perfect. Let's give it a go. And we sig trapped the error. I don't love what we're seeing there. I did inject a there's no oh there is. Okay. We segfaulted again. We are a couple instructions after the syscall. We're not going into that syscall, are we? Um, our RBP is unrecognizable. Um, Interesting. Oh, I guess it's just the negative. So that ED is that middle byte. Let's give this a go. Segfaulting, and this time RBP is something else ridiculous. RSP is reasonable though. What if I made them this? What if I just made them the same thing? We don't need those 3 bytes now. But perhaps we should continue to breakpoint and debug. Okay, we're at our sig trap. We are about to move RSP into RBP. Let me make this. Perfect. Okay. We've got RBP right now is a bunch of A's. RSP is pointing out that if we move RSP into RBP, and then we do the same for RDI, and we load up EAX, and then we call the syscall. I guess it makes sense that we don't have introspection into what happens in the syscall there. RSI and RBP look fine. Doesn't look like, basically doesn't look like the syscall got called. So what is a instruction, syscall I could call just to see if it is actually working? Also maybe if we run this on the actual process here, yeah, we don't have a shell. Strange. We must have our arguments set up wrong, but from what I can tell, it mostly seems right to me. Perhaps this is why we don't do a lot of Pwn. We're all so much better at RE. All right, let's take a look at what we're working with right now. Let's just close out everything. We can get back to it if we need to. Make a new file here. Paste from hex dump, escape string rather, and drop into linear again to look at this as a real function. Okay, so we're pushing the H. We are pushing the bin/s. We are making our BP be something sane. We're making RDI point to our argument. We are setting A to be the correct syscall number, and then we're calling syscall. Um, well, you know what? Why not? Let's set up RSI as well, or instead. What changes that E6 to an E7? Now I'm just kind of guessing. I should take another look at this. Where were we though? A couple bytes from the end. So it's an E7 that needs to turn into an E6. And what do we have here? We called the syscall and nothing happened again. Stores any in Erna 3. What is AU coming back as? Yeah, RAX is coming back with an error. We should have had, let's fix our shellcode back because that's what it should be, that E7. But then what is the error code when we run it normally? We're getting back that, we're getting back that. Does this give, is that the actual, indicates an error and an error number, but it's not the error number itself? Um, uh, what's the, I feel like that's negative 14 or 14. Um, you don't give me the numbers though. Yeah, that shouldn't matter. Um, it is curious though how they do this and not that. Um, though it doesn't matter too much. How does that change things? If I were to, um, that's the S. If I made it 73, um, H, can we go back? Yeah, I can see why it's escaping the slash though. Um, I kind of just want to, Make that null. Wrong one. And of course, we're going to want to delete that as well. Okay, let's try this one. Where we have just a slightly simplified beginning here, up until the 50. Don't want that. Copy this. For now, though, I haven't quite gotten to 16 bytes. Copy this as a... Oh, I guess I need to do 8-byte elements so that I can get the full escape string that I want. Cool. All right, so we have our new shellcode here. I'm going to put it into that, and we will run it again. Yeah. Oh, this time 4.2. Our bytecode didn't finish this time. Do we have a... Do we have too much or do we not have enough? Oh, we changed the size. So we need to change this jump. We need to go into... geez. Um, Size was hard to get right, too. So it was this, and now it's that. So it's two different. So let's make it two less. No, two more. 11 to 13. And where are we? We just jumped from... We did the move. We have that whole string. And then 7, 8, 8, 2. The next 4 bytes it says are invalid. So we have our... we have enough now where we should be able to specify 2 of those bytes. Because we've got 1, 2, 3, 4 over here. And we have 11. 11 plus 4. We need one more. Okay. And that is actually the whole thing specified, I think. The whole address. So we're not relying on any bytes to be 0 anymore. But it still doesn't love us. So let's push our BP. Oh wait, where are we? Um, so we have our buffer there. We're moving our AX to this thing. It looks like we've got um 8 bytes at our buffer there. We should have that 48. Yep. We should have that lines up through the 48 almost immediately does not. Oh, it does. 48 B8 2762 69 60 2F 73, and then we have this 68000 680. Ah, that would be the issue. That's 0. Where is it coming from? We have that might. Oh, we can't have the null pointer in our string, can we? Oh, that's why our shellcode was failing. I think we need just to write a null byte. I think we might need to write that null byte into the string. Makes sense why that code was doing so much. Okay, so let's roll back a little bit here. Um, oh, we know what our shellcode was before. That was our shellcode before, where this is up to the 50. Um, insert mode again. If I paste, doesn't like that. If I paste over here, doesn't like that. So we will have to paste our escape string. That looks good. If I go back to linear now, we have that push, move, push, and now the rest are our nonsense. So I don't need this RSP thing, but I would like to move a 0 into the byte at um RSP like +8 or so. Um, that is going to be a lot longer. So let's copy that out, undo it. We need to insert some 90s in here. All right. And now with that, we can edit in our Okay, interesting how it's giving me that. Um, Linear, we've got our not. We just want to move to like RSP plus something, a 0, and just 1 byte. Okay, and now we can delete these two 90s. Ah, but we still have a 0 in there. We don't want that to be 0. We really need to, I need to do load. Oh, you know what we can do? We can flip these two instructions and move RAX into that location instead of having a literal 0 in there. Oh, AL. Okay. So, um, after we do the initial stuff we do, which is what we were doing, we're going to, in our second stage now, we'll, instead of what instead of what we were doing, which is this 48 to 05 stuff. 0548 to 05. That is our move RBP RSP. We clear that. We move AL into that location. Um, what did I want to do here? Right, I need to copy these bytes out because we have new things going on. Unlock, insert. Let me throw in two 90s here just to help me. There we go. Then we are moving ESP into EBP. We're clearing EAX. We're moving that into the correct location. And this is what we need to change. Is if I change that 8 to be a 9, do we get exactly what I'm hoping for? Okay. So then that's the byte we need to change to make that 0 appear, and it should be RSP plus 1, 2, 3, 4, 5, 6, 7, 8, 9. I think it's 10. So let's try A. And now these are the bytes we want to grab out. Yeah. All right. We'll just do it as the byte string this time instead of converting it like I've been. We segfaulted in goodbye because where's my, oh, my RIP is up there. if we do the thing we've been doing, actually, let's put that breakpoint at the beginning of the second stage, because I just want to see all the instructions after me. We do not hit it. Cool. I didn't want to hit it. I didn't want you anyways. We have our shellcode phase one, and we're offsetting into it slightly too much, is what it is. Okay, we still segfaulted. We are at the ret. We're just trying to return from goodbye. 118. I'm trying to send. Yeah, what's happening? So we have our first phase shellcode, which we send second. We have our trampoline to our second phase shellcode. Our first phase shellcode, leave to be too long. Um, this is, I have 52 selected, 13 bytes. Um, 13, 14, 15. Okay, so that's the right size, just in case we were sending a little too much. We seem to still be, no, now we're not returning. Our RIP is something. Um, all right. If I can't do that, I'm gonna need to move this over. Put our breakpoint in our first stage again and try it. So now we are just not getting to our leak. If we look at this again, what are we doing? We've got this address that we ought to be overflowing into. The first thing that happens should be that, unless we're sending too much data. Oh, that could be, well, that's what I thought we were potentially doing. I thought I fixed that. We send text for node 1, we send exactly f bytes. Text for node text for node 2. So we send 50 to OA. Oh, is this messing with us? And has that been our problem the whole time? Yeah. All right. So I need to send um our new lines were throwing things off is what it was. I should have caught that. So we send OXE bytes um for node 1. We end it with OF05. Um yeah, that's where I meant to put that. And then text for node 1, we send exactly OXF bytes. We receive text for node 2, we send Alexa, stop. We send 15 bytes again, ending in 11, which is exactly right. Perhaps it does not need our new line. Why? Oh, I thought that's what it was. Command BP that. If we why is that not returning for us? If I just make that a send line, what happens? Is it the... Oh, it could have also been that I'm trying to send a null byte. Not sure. Nope, not the null byte. All right, so we send the first 15 bytes, the second 15 bytes. We receive node 1. Text, it tries to print strangely. We get node.next. We extract that. Um, oh, node 1, it shows the next on the buffer. Prints that in a weird way. What are your initials? And we give it that. Okay. Um, There we go. Okay. So we're back in. Oh, okay. Our syscall is running again. Um. Okay. So what were my theories at this point for what's going wrong? We have. Oh, right. We wanted to set that byte after bin/sh to be 0, which I believe we did, but we should just check everything. I already have a breakpoint in there that it does not seem to be obeying. Why is that? We debug, we continue, we send the first shellcode, we send the second shellcode with the breakpoint on it, we jump to that address. Okay. Um, so we have our shellcode phase 1. I just want that to breakpoint right now, but it's not. Instead, it is calling our syscall somehow, unless that's just a different syscall. No, looks like it's getting into our stack, but RIP FD F8, it is F0. The code there, um, is not what I expected it would be. Interesting. F8 FD. Oh, I didn't change. I didn't think I changed that, but I added the um, OXCC there. DD. I need D8. The difference of 6. What's this? Error, broken pipe. What did we do here? Up on the right there, we're getting a sig trap. And then the remote disconnects. Um, that was a guess. So, all right, I'll take this. We are now 3.8 and we're at 3D. How is it that I feel? Oh wait, no, yeah, we're still off. Um, we were at 11. If I do like 17, we're gonna be even further away, I would expect, but it's not. CD, C8. This, I'm changing the wrong thing. I must be. If I remove this. Okay, there we go. No, we have, we're at 8D and we want to be at 8.8. We want to be here. And then jump there. And we're seeing, yeah, we're just not. Why isn't this number changing at all? Um, let's see. We've got, where'd my paste from go? Paste from, escape string, um, and in here we're going to paste from escape string as well. And then we will grab all this stuff. Nope, sorry, this stuff. And this needs to be rounded out to 16 bytes before we can paste in the rest. Paste from escape string, drop into linear again, make a function here. All right. Um, interesting. 20 there. Really what's going on here though is something different. We need, when do those become, we need a whole nother set of 90s here. Perfect. So now if we're in linear view, we should see, okay. Um, this needs to be a 12, and now That should be right. Um, are we, what are we getting here? 38.0. C5, 3080, and we're getting 808. Okay, yeah, that's correct. And then 808 is the second buffer at 828, which is where we should be jumping, is the shell code, but we're putting in 808 here. No, no, that's correct, because we should be jumping into, unless I'm like flipping our buffers for some reason. We've got, yeah, 808, which should be executing first. All of that, which we're jumping to. I've definitely mucked something up here. We've got RIP is going to that. Um, is that the same number? 7FF C5 CC30. Yeah, okay. Except for the fact that it's wrong. We need to. Hmm. 20 minus the size of itself is correct. 16, 17, 18. Yeah, that should be correct. All of this should be correct. So what's going wrong? Is it the fact that we didn't copy that out as we did everything else? We copy this again. There are no internal null bytes. Just that one on the end. Copy as 8-bit elements. Ah, okay, that should be the same. But let's see. Yes, it appears to be the same. We are still crashing at 60D, and we should be going to 608. Okay. Why is it node 1 points at node 2? So we put the first stage of our shellcode into node 2, and then we jump to it. But for whatever reason, this line, which we haven't touched the entire time, now needs to be different. Okay, let's add the CC back. I should have to increment this to 13 now, or 10. Yeah, I think that needs to be 10 now. Um, so we didn't get our CC. Okay, wait. Let's just make this a little more bare bones. We need to. I don't care about that anymore. Let's literally just. Um, uh, we'll send 15 A's. And we will send just a couple CCs. Actually, I guess we'll send 15 CCs. We're going to get this leak, and it should be +8. And we should jump right into that buffer. And neither of these are going to be send lines, they're just going to be sends. Um, okay, so we're at our sig trap. It looks like we had. Did I remove my print? No, we should still see that. Why? Oh, because we're stuck here. Okay, so it is waiting for new lines. Is that the bug? We've got no node here. It has read line. Oh, it's calling get line, then it does need. Okay. So me trying to correct that earlier broke that, which we love to see. I should probably just be left aligning my shellcode with knobs too. Okay. So the lesson we just learned is we need to send line and it'll truncate, hopefully, anything that's more than what we're expecting it to be. Um, because we are stirring copying anyways. So I think that's what's been going wrong. Okay. So then what all did we change? We should have. This is what I'm hoping will work, I think. Okay. So we're reaching a strange address, which is okay if we make sure we're reaching our um but making sure we're reaching our breakpoint, our input, I should say. We are not, which we love to see. We want to, we'll jump right into that, and I'll just look at what the jump size is. Um, like we were earlier. So we get our segfault again. That's exactly 15 bytes plus our new line. Text for node 1 sent 10 bytes, received a bunch of bytes, sent 10 bytes again with a new line for the second input. Oh, and the second input needs that. Okay. So now we're at 4A8 and we've broken somewhere completely different, but we sent our 10 bytes. Oh, and then I think we're sending too many the second time now. That we want to be sending 10 bytes each time. So we have that OXF worth of bytes of input that we're pwning. Um, yeah, and then we should be breaking on, let's just break on the return from, where's main? Why don't I have a main anymore? What have I patched in this binary? Let's go to our history here. Okay. I don't know how we messed up that binary, but we have our read lines, we have goodbye. We could break on the call to printf. So now we are in printf, I assume. Um, Oh, that should be the other way around. Okay. So we'll set the breakpoint, then we'll continue. Then solve this. We can. Okay, it feels like we're in printf now. We are. If we return from printf, that should be fine. It's this next return, which shouldn't be. And we can see on our stack, we have RSP, RBP, and then in theory, node2 address, we just returned printf, node2 adder. What did it just print in printf? Oh, it just printed the node2 address. So we really want to continue to the next call to printf, and we can finish this one. Now we are in that goodbye, and now on our stack we should see where we are returning to. A. Wait, what? Shouldn't it be saying, what are your initials? Thanks. Something else? Um, we send all the A's, switching to interactive mode. Thanks you. Where are we? We are at that knob in goodbye. Right there. Um, we've just overflowed buff. So buff should be in here somewhere. Doesn't super look like it is. On our stack, we have a bunch of not that useful stuff. And we are about to jump to that. What is this? A12EB? Yeah, it's our. All right. There is something here I am missing. What am I missing here, guys? Um, I could have sworn when we do this, Time to fire up Sidekick. You're not wrong, honestly. You need to install Sidekick. I was testing the new release for Sidekick on stable, and it is rather impressive. Um, I'm very excited for it to come out. Unless Sidekick doesn't work on this version. Let's try restart. Oh, I should probably. It doesn't matter. It's still not enable, please. I haven't tried installing Sidekick since the plugin manager update. Um, there could be something wrong here. I'd be surprised if anything was wrong here. There we go. Why won't this exploit script work? Hmm. Perhaps I could have formatted that as code. I missed the new Sidekick, watching the old Sidekick churn. We can also see how his old Sidekick isn't using the latest models yet. Um, let's see what it has to say. Stack layout mismatch. We need to reverse a little bit. Okay. Um, oh, is it taking out our last byte? No, it was working before where it was jumping between the two buffers. Hello? It's saying that this won't open overwrite. I think it's going completely off. It's doing worse than I am. Yeah, and it doesn't know that the stack is executable. So if I tell it the wait. Honestly, sometimes I find the process of explaining what you're doing to Sidekick to be the most helpful thing. Um, if you type it out to an AI, if I'm jumping from, yeah, if I'm jumping from node 2 to node 1, I am jumping forward. That's correct. Okay, so that's not what there is to worry about. Um, the stack is exact. I'm getting the leak correctly and finding the buffer where shellcode lives. I'm overflowing RIP correctly to get to our buffer um, as well. Let's see what it has to say about that. Oops, over here. Your overflow is not 11 bytes to RIP. The saved is 19 bytes after the. Um, that okay. It's 17, isn't it? No, it's no, it is 11. It's definitely. Bytes 0 to 10. So the offset is 3 bytes to RIP, 8 bytes to. Oh my gosh. Um, and 8 more to reach, meaning that. No, it's just wrong. Right? Because we have. If we take out. Well, we need that, but if we take out that trampoline, so we're just not worrying about anything. This is ASD. This is just shellcode phase 1. That's the address of the shellcode. That should breakpoint. Um, yeah, let's just not do that for now. Um, so we didn't hit our thing. Okay. And it's still wrong. How is it wrong? RIP is trying to be. Where are we? We've got this here. So we could break on. Yeah, sidekick's not being helpful here. Um, you know what we can do though? We can cheat. So let's see what they're doing. They've got. They move RBX. I assume that's. What is that? Um, what is this? Nothing. Oh, but they invert it because they're trying to not have null bytes in there. Okay, that's another interesting way to do the slightly more complicated thing we did. Um, I gotta remember that one. So then we push that. We push RSP. Oh, yeah, that's fair. That's very fair. So we can, oh no, that's just the pushing and popping RSP into RDI. Um, then it's pushing, why are we pushing? Oh, because that's the wrong shellcode. That's the actual shellcode. We negate, we push RBX, we XOR EAX, XOR ESI, we do that, we pop RDI. This is incredibly similar to my shellcode. Um, and then they pack it a little bit more creatively. I like that. Let's steal this. So if we have our, in theory, contiguous shellcode, we're going to, oh, but we don't know where the instruction boundaries are here, which is why I've been doing it manually. But the manual thing shouldn't be the problem, except that jump is sometimes weird. So we can try to make that the actual calculation as opposed to what I've been doing, which they do as well. So let's steal that from them. EB, um, did they hardcode this as well? That one, am I going crazy or does this not use N? Okay, I'm not going crazy. But I kind of am. So I'm going to finish up here. Sorry we weren't able to finish this challenge. I was very much expecting us to, but what's going on? What are we missing? Um, for some reason I think everything we have except for the shell code is pretty much correct. I'm not 100% sure why we kind of just stop hitting our shell code in several different instances, but um it does seem like there are tweaks for us to do here. I think we would have been finished a lot quicker if shellcraft was up. Because again, I know there's a or not shellcraft, the shellcode database. I know there's a shellcode that is actually small enough for us on Shellstorm, but it's down right now. Um, we can also steal an amount of the solver shellcode. Um, except this here was accidentally hard coded, so that's not really helping us. They are following the exact same pattern we were doing as well. Our override is correct. Our address is correct because we're doing. Oh, they're jumping to one then two, which is interesting. Instead of two then one, it looks like potentially. Yeah, yeah, definitely. They're going to one then two. Um, which doesn't really change anything. We could go to one first if we wanted to, and then jump backwards to two. I think it's easier for us to jump forwards instead of having to jump back, but maybe I'm wrong. Um, gosh, so must yeah, I really think it just comes down to our choice of shellcode. Because we were also even able to bounce between them. We could even see this is called executing. It just had some error in it. I think that's because we didn't have the correct null terminated string. And if there's anything we should steal from this other exploit, it's definitely negating the actual bytes here. Let's give it one more go. Let's put some 90s in here. Let's make a function at this address. Drop down to assembly. So now we have this. That is exactly what I thought it was. We're now at the of our exploit 90, 90. We only have 2 bytes after that. Which should be enough for a jump. So let's copy that out. And this is our, I don't like how it does that. I want the copy as, uh, there's probably a dozen better ways to do that. I don't care. Um, we can grab our new first phase of our shellcode plus our jump. And if I throw that into Binja, that is a EB12. EB12. We know we have. I messed something up, didn't I? We have 3 bytes, not. No, we only have 2 because we have the new line after that. Okay. So then we have the 16 bytes between the 2 user controllable buffers. And then we have. This should be a push and everything else. So if we paste from the escape string, we drop into linear, we look at this function, we didn't put in the jump, which is right here, which is the EB, it's now locked, EB12. And that is 1 too far, so EB11 like it was earlier. EB11. Um, I didn't want it to make duplicate functions there. We now, can we do this into AX and have it be the same size, please? Thank you. So AX, we push AX, we move ESP to EBP, we clear AL, we move, oh, we don't need that instruction anymore. 25 to the 04. We're not doing that nonsense anymore, but we are incrementing. We don't need a NOP. Okay, so we have the first bit of our shellcode, EB1190, or EB11 enter, EB11 enter. We then have our second part of our shellcode, copy as 8-byte elements. I want, okay. All right. We've simplified our bytecode significantly, our shellcode significantly. This, in theory, should still work if nothing's behaving weird. Let's go ahead and run it. Okay, so where'd we crash? At the return. Why? Okay, if we look at our stack here, that would be why. We tried to do what the AI told us to do, and it was hallucinating. Okay, now we're crashed again, but this time we sent our text for node 1, we sent our text for node 2, we received our thing E70, convert that to E78. We P64 that. That is correct. But why is it looking wrong? What are your initials? We send all that, and then we send 7F, FC, C0. Oh, no, we do. Okay, 3E, 2E, 7E. Okay, so we are sending the correct address. And then this should be saying thanks again, all that nonsense. And we should have jumped there, which it looks like we did. We got our syscall out, and Rx is an error again. Um, what? I don't want to have to call Erno in shellcode to figure out what's going on, but we might have to. Um, why aren't we getting shells? Let me compare our shellcode again once to the answer. We have a move of that wonderful number that we negate. We then push it. We guys, pointers are 8 bytes. It's important to keep that in mind at times. I was a little too focused. No, go back. A little too focused on minimizing our shellcode that I forgot I broke it. I think this is what's been wrong the whole time. So 50, at this point, I'm just going to copy this over by hand. 4, 8, 8, 9, E5. Okay. I think that was it. I've said that a few times though, so we still have an error there. Is my shellcode even valid anymore? Let's finish comparing it to the answer. Um, we've got our beautiful constant. We negate it. We jump to the rest of our shellcode. We push what we had to the stack. We take I've also had the wrong um I need RDI, not RBP. Oh, I deleted the wrong that might have been a bug for a while too. I deleted that other move a while ago. So we've got now 54.8 E 54.8 E9 E7 here. We want that in ESI RSP TRDI. Okay. Um 48 to DB. EB. EB. Well, can I? Nope. Um, paste from. There we go. Oh, that is different than what I had. I never copied over the RX changes, apparently. Let's recopy all of this. Is it right? I think it's right. Ah, all right. Copy as 8-byte elements, all this nonsense. We don't need any of the 90s. I already have the EP11 being appended. Okay. Please let this work. Aw. Still getting an error here. We are still running our syscall though, which is a good sign that it is continuing to execute. It's just executing with the wrong something. So I don't think I have room to insert a breakpoint in our first buffer. I can't set it in our second buffer though. Sigtrap. Okay, so we are getting to our code correctly. And if I single step until the syscall, Rx is 3b, RDI points at bin/sh. Um, they do clear their ESI. I have been assuming that's not important, but that could be fraught potentially. So let's steal an XOR. How much does that cost us? Um, how many bytes am I inserting? It's an XOR. I don't know. So it's 2 bytes. 3 1 F6. Um, how does this go? We're at our trap. Oh, I think we did it. So in the end, I think the big thing I got caught up on was um oh no, not on the line. Not quite. Did it? Oh, that would be why. Let's take the breakpoint out of our shellcode so when we go to exploit it, it actually works. Um, yeah, so I think the big thing I got caught up on was that ESI. Okay. We did it, guys. We got the shell. Um, yeah, okay. So the big thing I got caught up on was I had one of my register sizes slightly wrong, ESI instead of RSI. It probably would have been best for me to keep the shell coding potentially all within here and assembling it in here so it was easier to change things and iterate on them so you could change registers and stuff. It was nice seeing it in Binja just because we could visualize the literal stack space between our two things and get this jump correctly. I got caught up on that jump for a while. I might have had it right earlier on and other things were being the issue, potentially, but this relative jump is simpler than I was trying to do a call. Um, and then inverting this bin/sh so you don't have that null byte is kind of the last trick, but we had ways of working around that one. I think the big one was just I was copying from ESP to um, EDI. and at other points, a even different register. And then I guess finally we needed that XOR was the missing piece I had, the last missing piece we slotted in. Okay, so that's the first of today's challenges done. I did want to go over a ROP challenge, which we're not going to have time for, but we can do that next time. We can also do. There is one thing in Baby Heap I wanted to show. We've been doing it already. The TLDR on this is it's a 5-item menu heap challenge, and you have this extra case break. I just think it's nice that if we look at case 5 here, we can notice case 5 is just before our jump to the top of the loop. Otherwise, it brings us to the end. So if I patch this to be a NOP, or even better, if I patch it to be an interrupt, we could have just a breakpoint as a case while we're debugging this heap challenge. That's all I wanted to show you about the heap challenge, but um, I guess next time we'll have to maybe honestly redo the shellcode one, um, just so we do it so we don't get anything wrong next time. But I would like to do Ropity. Next time, actually, next stream we'll probably be looking at Sidekick, the new Sidekick release, and just seeing how wonderful and amazing it is, because I promise you, it is really, really cool, and I'm excited for you all to be able to use it. But until then, thank you for sticking around. This has been another Binary Ninja live stream. I hope you enjoy, and we will see you next time. Bye, everyone.